Okay, this is repeated linear factors, example 2. Here's the integral. The denominator here has a factor of x plus 1, which is considered linear, with an exponent of n is equal to 3. So you can read through this description again from case 2. We're going to need 3 fractions, one with a denominator of x plus 1, then x plus 1 squared, followed by x plus 1 all cubed. The numerators will be a, b, and c respectively. So now we picture moving to a common denominator. And that denominator, of course, will be x plus 1 all cubed. Let's make our long equation. A currently has x plus 1 under it. In moving to this denominator, it requires x plus 1 all squared. Go on to plus b. Look what's under it currently. Look what we're heading toward. It needs an x plus 1 factor. Lastly, we have plus c. It already has the correct denominator, so there will be no factor here. This means that our original fraction is equal to this one, and further, our original numerator, which is x minus 2, is equal to this numerator here. What roots can we use? Well, there is only one root possible, and it is x equals -1, so we begin with that. If we substitute -1 on the left, we'll have -1 subtract 2, which is -3. On the right, we will have a times 0 plus b times 0 plus c. So from this, we find that c is -3. We've run out of roots and we still have 2 unknowns. We do not know the values for a or b. It is too soon to choose an arbitrary number. Remember, we used that in example 1 when there is but 1 unknown. With 2 unknowns, we need yet another skill. So what we do is we compare coefficients of like terms. In this equation, what kinds of terms are there? So you have to picture this expanded right here by FOILing. So it would have a squared term, a term of degree 1, and a constant term. This one would have a term of degree 1 and a constant term. Here, just a constant term. So throughout the left and right sides, those are the 3 kinds of terms we can expect. So let's look specifically now at the coefficient of x squared, since that's the highest power in this equation. In the left side, there is no x squared term. That means the coefficient of x squared on the left side is 0. We have 0x squared plus x minus 2, in other words. On the right side, what is the coefficient of x squared? The only x squared term would be here, preceded by the coefficient a. So we would have a term ax squared if we actually expanded this out. There are no squares present anywhere else, so this gives us the equation 0x squared is ax squared, from which we get 0 is equal to a. So that means we will not have this fraction present at all. Okay, now that there's only one unknown and it's b, we can choose an arbitrary value for x and substitute it, because we know right now that this is -3 and that a is 0, making this whole term gone, by the way, of course. So the only unknown is b. So this is when we can choose an arbitrary value to substitute. The only value we've substituted thus far has been -1. So I will choose x equals 0. Starting on the left, 0 minus 2 gives us -2. On the right, remember this whole term is gone since a is 0. So where do we go? To here. b times 0 plus 1. And on the end here, we have plus -3. So we end up with this equation. -2 is b minus 3. To solve for b, you would add 3 to both sides. So b is -2 plus 3. In other words, b is 1. And we now have the values of a, b, and c. So this is brand new for you here. And we need to use this coefficient method when we have more unknowns left. We've used up the roots, and the number of unknowns is more than 1. When the number of unknowns left is just 1, then we can choose an arbitrary number to substitute. Okay, let's put our values for a, b, and c into here and complete the integration. Look, this one is a definite integral also. Okay, so what are we integrating? We are going to be integrating, not this one since a is 0, but this one. So 1 over x plus 1 all squared plus -3 over x plus 1 all cubed. That's what remains for us to integrate. In order to integrate these, we have to write them x plus 1 to the -2, followed by -3 x plus 1 to the -3. Perhaps I'll just leave 1 dx here. So I'm going to get rid of this one. Okay, there we go. Now to integrate these, we could use a u substitution. However, u would be x plus 1 in each case, and the derivative of x plus 1 is just 1. So du would be equal to dx. So in other words, we can skip that step. All we have to do to integrate is add 1 to this exponent, and to make sure that in front will be 1 over the new exponent. Same thing here. We add 1 to the exponent, and then underneath here will be -2. And then we're going to substitute between the given limits. I would prefer to substitute once I've rewritten it, but that's, you know, kind of a personal thing maybe. You can choose to do differently. So I probably would do this first. Okay, this will now be positive. I would do this, and then remember how this works. First, you substitute 2 throughout. So we will get here -1 over 3. Plus, substitution of 2 here gives me 3 squared or 9. So we're going to get 3 over 18 or 1 over 6. Okay, now I substitute 0 into this term. I'll get -1 over 1. And then substitute 0 into this term. which gives me 1 squared here. So 3 over 2. Like that, put this into your calculator and you should finally get your answer of -2/3. Okay, there will be one example that follows this where we are again going to have to use this coefficient method. So don't be worried if you're not quite sure of that yet. You'll see it in example 3 as well. Okay, great, thanks.